let's take a look at an application problem that may involve finding the centroid of a triangle. The diagram shows the plan for a triangular piece of mobile. Where should the sculptor attach the support so that the triangle is balanced? Okay. We have a plan for a triangular piece of mobile. We have a triangle, and we're trying to find where we need to attach that support so that the triangle will balance. Recall, the centroid is also called the center of gravity. So let's see if we can find the centroid in this triangle. Well, also remember median. A median is a segment that goes from a vertex or has its vertices has its endpoints at one vertex and the midpoint of the opposite side. And if we can find where those three medians intersect, then that would be the centroid, also called the center of gravity. Okay, let's take a look what we have. Let's see if we can find the median from point P to the midpoint of the opposite side. Well, I need to know the midpoint so that I can connect this point to the midpoint of the opposite side. I know the coordinates of the opposite side, know the coordinates of the endpoints. If I use the midpoint formula, then that will give me the coordinates of the midpoint. Remember the midpoint formula? Let's use it. And we're going to call that point M. Whenever we find the coordinates of that point, we'll call it M. And according to the formula, we need to add the x coordinates, which are -6 plus 0 divided by 2. Add the y coordinates, 10 plus 5, divide by 2, and that should give us the coordinates of the midpoint of this line segment. -6 plus 0 is a -6 divided by 2 is equal to -3. 10 and 5 divided by 2 is equal to 7.5. Okay, so that's the midpoint of this segment. I'm going to go ahead and call it M. Okay, I'm going to go ahead and write the coordinates down. -3, 7.5. Now just check. Look at this. -3, 1, 2, 3, 4, 5, 6, 7.5. I am going to draw that median, because I want to find out where the three medians intersect, or at least two of them. So line segment MP is one median. Okay. I also noticed something else. Look at that median. It is parallel to the y-axis. I know the equation of that line. If it's parallel to the y-axis, what's true all along this line? X is a -3. So the equation for this line is x equals a -3. Okay. Let's see if we can find another midpoint. What about if we go from point R to the midpoint of the opposite side? Somewhere there's a midpoint. I know the coordinates. Let's call that point N. I'm trying to find where the midpoint of this line segment is, and then I'll have my median. Once again, I'm going to use the midpoint formula. I'm going to add the x coordinates, which is a -3 plus 0 divided by 2. And I'm going to add my y coordinates, which is 10, which are 10 and 0 divided by 2. Now let's simplify that. Negative 3 plus 0 divided by 2 is equal to negative 1.5, and 10 over 2 is 5. Now, so it looks like our other midpoint, point N, is a negative 1.5. I'm going to go here, and up 5. Gosh, it checks. It's on that line. So let's call that point N, and the coordinates are negative 1.5, 5. Now let's draw that median. Look at this. The median, line segment MP, median, line segment RN. Where do they intersect? They intersect at 1, 2, 3, negative 3. I'm going to negative 3, 1, 2, 3, 4, 5, and 5. That's the point of intersection. And recall, let's see, the equation of this. Let me go ahead and, since I wrote the equation of this line, what's the equation of this line? The equation of this horizontal line parallel to the x-axis is y is equal to 5. Okay? So I have two equations. One equation of one median, MP, line segment MP. The equation of that median is x equals a negative 3. And what about this other median, which is line segment RN? The equation of this segment right here, which is a median, is y equals 5. And I can see where those two medians intersect, which is what? Negative 3, 5. And that does check. Anytime using the systems of equation, the intersection of these two lines is a negative 3, 5. So this is where the sculptor needs to attach the support so that it will balance, which is called the center of gravity, right there.